This is problem 29 of chapter 15 from the textbook Stats Modeling the World. Okay, if you've seen some of the previous videos or worked on these problems, you can see that we've had this data before when we looked at exercise 11. We have two categorical variables, blood pressure, and we're interested in if you have high blood pressure or okay blood pressure. I believe this is for men's health. Okay, and then cholesterol levels, high cholesterol, okay cholesterol level. So we want to do a test for independence. We want to see if blood pressure is independent of cholesterol level. So a nice test for independence using the probability models or formulas that we're using. Sorry. Is to ask, what's the probability of A given B, and is that equal to the probability of A? Okay, and so I believe Ms. McComb also does this, but we put a little equal sign right here. So we're asking that question. We're not saying it's the case, like a regular equal sign. We're asking. We want to find out. So if the answer is yes, then we know the condition doesn't matter, that the probability of A given B is just the same as the probability of A, so saying there's some condition doesn't matter. So if yes implies independence. Okay, but if no, if they're not the same, then they are not independent. Okay, oops. Okay, so let's just try it. So what I was thinking is, I don't even think it matters where you start, but what I was thinking is, what's the probability of having high cholesterol given you have high blood pressure? Okay, and then let's ask, is that equal to the probability of high cholesterol? Okay, so if they match, then we'd say they're independent. Okay, so on this side, I'm going to translate this because I know that this is like a conditional probability. So the probability of A given B is equal to the probability of A and B happening divided by the probability of B. Another way is also the probability of both divided by the probability of the given. So here, this becomes the probability of high cholesterol and high blood pressure divided by the probability of high blood pressure. And we still want to know, is that equal to the probability of high cholesterol? Okay, so you could probably pull this out of the table pretty easily, but let's just check. So the probability of high cholesterol, we would have to add these two, right? We want to get this marginal distribution right here. So it's going to be 0.11 plus 0.21. And over here, the probability of high cholesterol and high blood pressure is just 0.11 or 0.11. And then the probability of high blood pressure, well, we would have to add these two to get that marginal distribution. So it would be 0.11 plus 0.16. Okay, so over here I get 0.38. 2, and I'm going to use my trusty calculator. Oops, not yet. I'm going to use, this is going to be 0.11 divided by 0.27. Now I'm going to get my trusty calculator out. So 0.11 divided by 0.11 divided by 0.27. I don't trust that number. 0.11 divided by 0.27. Oh, I guess it's right. Okay. So we get 0.407. So let's just say 0.41. So 0.41, and that, so we were asking, but here we can be a lot more definitive. These don't match. So therefore, for the condition matters, so high, no, not high, just say, let's just say blood pressure is not independent of cholesterol level. So they're not independent, okay, according to this test. Now, just a word of caution: if for some reason you get that they are equal, you might want to test another combination, especially if you have, I guess when you have two variables and they're just binary, you have two outcomes, it's not so bad. But if there were more than two categories, then this could happen. If you have, let's think of it as using segmented bar charts. If we had segmented bar charts, and maybe for A they're basically the same, but B is a lot different for the other categories. So you might want to check more than one if they're the same. But if they're not the same, then you're done. You've shown that there's some that this condition matters in some way. Okay, good luck with this.